Okay, good morning, kids. Today we're working on the Type 5 tables and Riemann sums homework. I assigned two problems. One of them is calculator active. The second problem is not. The first problem has to do with a zoo, a number of entries, and this is from 2010, number 2. So if you're keeping track on that chart, please make sure you highlight this one so that, we can make sure we're getting them all done. Okay. So we talked about yesterday what could be on a question like this. We're certainly looking at this is going to have some sort of Riemann sum, average rate of change, maybe some max or minimum values, but we'll go through that as we get through this problem. A zoo sponsored a one-day contest to name a baby elephant. Zoo visitors deposited entries in this special box between noon and 8 p.m. The number of entries in the box T hours after noon is modeled by the differentiable equation function. Differentiable function implies continuity, by the way. Values of Eft and hundreds of entries at various times T are shown in the table below. Above. Use the data in the table to approximate the rate of change in hundreds of entries per hour at which the entries are being deposited at t equals 6. So this is an average rate of change problem. We are looking for e prime of 6, which is equivalent to e of 7 minus e of 5 over 7 minus 5. And because it's a calculator active question, you can now just compute it in your calculator, but what we're doing is we're subtracting this and we're subtracting this, and I believe we get 4, right? 8 over 2. To show the computations that leads to your answer. This is the computation that leads to your answer, and we need 400 entries per hour. And so in terms of grading this is going to be a 1-point question. So that's one solid point we have now. Okay, part B says use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1 over 8, 0 to 8 e of t dt. Using correct units, explain the meaning of 1 over 8, 0 to 8 e t dt in terms of the number of entries. So this is average value, which won't be tested, so I don't think you'll see interpret the meaning of this, but you still will be required to find 0 to 8, and so multiplying it by an eighth isn't going to kill us. I've got 1/8, 0 to 8, e of t dt. And what you're looking for here is we've got an eighth times a half, because everything's times a half because it's a trapezoidal problem. And then you're going to have to find the change in x for each one. So in the first interval, I've got a change of 2, right? So 2, and then that's going to be times 4 plus 0, plus a change of 3 times 4 plus 13, plus a change of 2 times 13 plus 21, plus a change of 1, plus 1 times 23 plus 21, big parenthesis. Okay, and so now what we're at here, by the magic of a calculator, because this is a calculator active question, we've got 10.687. And so what this represents is the average number of entries in the box between noon and 8 p.m. Okay, so there's part B. Give me 1 second. I'm going to have to add a page here. Okay. For part C, it says at 8 p.m. volunteers begin processing the entries. The process entries at a rate modeled by the function p, where p of t equals t minus 30t squared plus 298t minus 976 entries per hour for 8 to 12. According to the model, how many entries have not been processed by midnight? Okay. Oh, let me point the other problem. By the way, you have one for the trapezoidal sum, one for the approximation, and one for the median. So part B was a 4-point question. I think what you'll see is the eighth be dropped, but I think that'll be okay. So I think what you would have to do is take for this part, now we have an 8 to 12 of P of t dt. However, before 8, our initial amount, our E of 8 is 23. So it's 23 minus this rate at which they are going to be processed. Okay, so this you can do on your calculator, and it should turns out to be 23 minus 16. So we have 700 entries. And if I was guessing that something got forgotten here, I think it's going to be this 23, this initial amount that goes with E of 8. That's the entry amount. But maybe not. You know, I think it's something that maybe I would forget. So this integral is the first part, is the first point, and then here's your second. So this is worth 2 points. Okay, part D says, according to the model from part C, at what time are the entries being processed most quickly? So this is an Evt problem, right? So we're looking for P prime of t to be equal to 0. You're going to use your calculator. You're going to find the intersection of these functions, and there should be 2 times that we get here. 9.183,503, and t equals 10.816497. This is where we're going to make that chart. Our initial time is 8. We have T1 and T2, so I'm going to put T1 here, T2 here, and then 12. EVT means we have to consider all of these things. You're then going to put these candidates, and so the first thing you have to do is, for point-wise, you have to consider this, right? This identifying these candidates is another point, including recognizing 8 and 12, and then your answer would be what would matter. And so we're going to figure out what these values are. We've got 0, 5.088662, 2.911338, and 8. And now, by the way, this is also going back into, that original function we came up with in C, right? That's the model that we're using right here. So make sure that when you're putting this in, you're getting 0, so it'd be 23 minus, the 8, so you'd be at 0 here. Okay, the answer with the justifications, the last part. So you want to say that entries are being processed most quickly. Is that what that says? Yeah, it's a weird word. Quickly at t equals 12. Okay, because the question says at what time. And so there's your third point. So we got 3, 2, 3, 1. I'll make another video for the second problem. I'll see you soon.